Welcome, everyone. Welcome to Intelligent Automation, the force multiplier for COBOL modernization. I'm Gregory Saxton, Field CTO at CloudFrame, and happy that you're able to take a few minutes out of your day and join us today. There's some great definitions, around what is intelligent automation. I think foremost, it's a strategy. There could be tools. What I like to focus on at this step, though, is just sort of take a step back and not think just about something in the context of tools. I also like to just think about sequencing of work. And I'm a big fan of Doctor Who. I don't know if there's any Doctor Who fans in the audience, but favorite saying of his is first things first, just not necessarily in that order. So you're thinking about modernizing your system, converting from, say, COBOL to Java or .NET. And what if I told you the first step of this transformation was to actually do nothing or almost nothing? What if the first step was simply to adopt a tool that would let you do some in-place cost optimization, a tool that would let you shift COBOL workloads over to the zip engine or potentially out to public-private cloud? No changes to your source code, no changes to your data. Effectively put that in place to help you self-fund your modernization. Well, I'm from the future, and I'm telling you that tool exists, and you can look at it tomorrow. It's called CloudFrame Relocate. So great, you put a tool in place to create a simple, sustainable program to reduce your costs and help pay for this legacy modernization. You're already building fans internally. They trust your strategy. That's intelligent. Now let's get on to the next part about automation. A tool like CloudFrame Relocate works by cross-compiling and transpiling code to Java. So all the while you're getting the benefits of reducing the cost of COBOL workloads and maybe experimenting with shifting workloads to the cloud, you're also getting the opportunity for your enterprise to get comfortable running and managing Java workloads for what used to be in COBOL. You have the opportunity to inspect the code and have confidence in the code quality, the performance, before making the commitment to a tool and to a transformation program. That, to me, is intelligent. And that's the way you want to go about thinking, of your modernization journey. So why do you need IA? Well, oh my God, not to pick on COBOL, right? Languages evolve over time, and COBOL's been evolving over about 60 years. And, I love great quotes. You can see some of the complexities up here that have occurred with languages like COBOL. And some of the worst are these things like unconditional branches, the go-to, or the things that were done when compute and storage were so scarce with these byte-oriented languages like COBOL. So things like COBOL redefines. Great saying, right? Good designs are similar in their traits, whereas every bad design is bad in its own way. But the code didn't start out this way, right? A lot of this code, it's not that it's necessarily terrible, it just needs some refactoring by an intelligent tool that will put it in a language like Java, modern object-oriented, and allow you to pick up and maintain it. There's another great saying by an old boss of mine, Ian Koenig. Good code is enhanced by a generation of engineers until it becomes bad code, where it then lives forever because it does exactly what the business needs it to do. And that is the state of COBOL in the business environment today. By and large, it is doing exactly what companies need it to do. So the question is, how do you solve the problem of modernizing a system with no representative business or functional requirements and questionable code quality, despite it doing exactly what your business needs? So, context. I was about to jump into the details. So you think about all this code, you think about your business processes. Everybody wants to start from scratch. What's often not even thought about when people go on these archaeological expeditions to try to recreate requirements, for a system that's been around 10, 20, 40 years, is you're not even thinking about little things like the compiler options that were used when the code was compiled. In a language like COBOL, that has some fairly significant implications on your computations. The point is how do you go about discovering everything you don't know about the system you want to rewrite? A trend in the market today is tools that have been around a long time that don't quite produce the code quality you're looking for. I've seen these morph into tools that are used for business rules extraction. And that has some merit, I guess, but you're still in this position of greenfield. And my thinking is, what if instead of a greenfield approach, take a step back, right? What are the changes? What's causing you to modernize this system? Cost is not enough, right? Cost is not the driving force. Cost is typically an extra benefit if you're able to do this in a way that reduces costs, and with CloudFrame you can. What are the business process improvements you could deliver faster with a modern Java application, right? A DevOps team empowered with cloud infrastructure, an automated tool chain, automated testing, static quality, code quality analysis tools, and all the other goodness that's come out of this DevOps transformation that's occurred in development. Now ask yourself this. Yeah, these people will be more productive, they'll be energized, they'll be delivering work faster, making improvements faster, adopting innovations that are freely available in this Java cloud native ecosystem. So here's the next question to ask yourself. Do you want to start delivering that high impact business value in 3 months or 3 years? Because if you want to deliver it sooner, you're going to have to start sooner, and you're going to have to consider an automated approach, right? The only sustainable competitive advantage is being able to learn faster than your competitors. There's a lot of people who still think they need to start over from scratch. I don't think you do, not all the time. So what does automation solve? Well, large companies have thousands of engineers. And if you were to talk to some of these people, what you're going to notice is that they're not sitting around bored. They're fully allocated to projects. And demand for engineering talent, it's just globally exceeding supply. We've seen the pivot to digital transformation that the pandemic brought. That hasn't stopped. It just keeps accelerating. And you think about greenfield development as a strategy for most of your portfolio. I can tell you from having been on that journey, you're talking 10 to 20 years. It's going to take a really long time. You could try to speed up, right? You could get outsourcers involved and outsourcers partners. It can be really helpful. But the whole reason you're rewriting this is you have an end state, architecture vision in mind. You have a very strong conviction about what good looks like. And it becomes very difficult to be orchestrating all this change at once with multiple parties that don't share your same vision and value system, because what everybody's really focused on is just getting to the finish line. And let's face it, time is money. Time's become much more costly these past 30 months than perhaps in the last 30 years, hell, right? And why spend years rewriting code that works when you can automate it in a matter of days and weeks? Like, that's the thing where I just keep scratching my head. I get it. Some systems, for whatever the compelling reason is, it makes sense to rewrite them from scratch. But if you're looking at a portfolio of hundreds or thousands of systems, you can't say that every one of them needs to be rewritten from scratch. So when I think of benefits of automation, I've started talking about these, right? You want to start sooner, you want to finish sooner, you want to spend less. Intelligent automation, a tool like CloudFrame, gives you the opportunity to invest dimes to save dollars. You got a lot of smart engineers in your organization. You partner with companies that have smart engineers. You want to focus them on the most important work that can't be automated. If a machine can solve your problem, why are you paying humans to do it? That's the basis of DevOps and SRE. You want to remove toil from work, right? You want to have consistent outputs, identical outputs. CloudFrame guarantees the code that we generate will produce identical outputs to the original COBOL code. Think about how much time you can save with black box testing with a guarantee like that from the vendor. look, if our code that we generate for you doesn't do exactly what the COBOL code did, it's a bug. We fix it. We take this serious. And scale, right? Think about the size of your portfolio. Here's the difference with intelligent automation. 500,000 lines of code, a million, 10 million, 50 million. Yeah, we have customers we're working with 50 million line of code portfolios, and that's not everything. But what is really cool is that you could take a million, 10 million, 50 million lines of code and convert that in a few hours or days. You do that the hard way, greenfield, you are talking years to decades. Now, think about this. You're already running this code today. You're operating it, you're maintaining it. It's doing exactly what your business needs. Why not just convert it with a tool that guarantees that it's going to put it into a better place, a modern tech stack, DevOps tool chains, cloud ready, and it's going to do exactly what your business still needs it to do. I look at this and I say the sheer economics of this opportunity demand that you can't ignore this. You got to kick the tires. So let me give you a couple examples too of where we really differentiate. CloudFrame is based on a modern tech stack. There's tools that have been around 20 years. They may be gradually refactoring, and that's great, but you can't solve a modern problem with a legacy solution. And the modern problem we're trying to solve here is, right, we want to modernize towards microservices architecture. We want to adopt as much of the Spring ecosystem as possible, particularly, things like Spring Cloud, if you're looking for code neutral, cloud native type architectures and designs. So we've settled on the most widely adopted open source solutions. Our strategy is that, we want this code to look like it was built by your better engineers. We've designed our microservices framework so that the things that you need in your interim state, like emulation of legacy file systems, these are just dependency injected beans that you can replace without touching the rest of the code. So, our customers tell us horror stories about other tools they've tried or they've used. The code generated literally required Java developers to be cross-trained in COBOL and mainframe concepts just so they could maintain the Java code. Now ask yourself this. If you have to train people in COBOL, why the hell are you moving to Java? Just train more people in COBOL if they're willing to learn it. I mean, there's got to be a compelling reason you're doing this. The other thing that just amazes me too is the idea of code bloat. When you start with CloudFrame, what you're going to find is that you're going to have source code that comes out of our tool that is actually fewer lines of source code in Java than the COBOL code you started with. You're not going to find that across the landscape of companies that specialize in this. Then why is that? Well, maybe it's because we're perfectionists. Maybe we try just a little too hard to delight our customer. Maybe it's because of, we're engineers at heart, right? We wrote code, we maintained production systems, and we're really concerned. Like, we want to help our customers. We want to solve this problem. And myself, our CEO and founder, like, we've looked at this problem from different perspectives. And we just say to ourselves, like, it doesn't have to be so difficult and fraught with peril to take legacy systems and modernize them. And the code should be good. You like I said before, you really want it to look like your better or best engineers wrote it. And think about this. If you're converting COBOL code to Java, and you're eventually or immediately converting your code out of a mainframe data architecture to Unicode ASCII, what the hell are you paying a runtime license for? This is literally your code, and now you're paying to run it? It makes no sense to me what is going on in the marketplace. So the other thing I think about is, what is intelligent automation, right? What are the questions to ask, right? You'll work with architecture teams, and I know this because I was one of those architects in my role in industry roles that's looking at the code coming out of these tools. You'll work with development teams. You definitely want to pay attention to code quality. Compare multiple products. Absolutely. Look at the code bloat that comes out of them. Ask yourself, can I maintain this? Will I have a team of people who are absolutely delighted to say they work on this system? Or is it going to be the same drudgery that led to outsourcing COBOL in the first place? The mistakes. We have built a tool that really empowers customers to sort of do it yourself, or to do it at scale in a very rapid way with your systems integrators. But as you take this journey and you move out of a predominantly IBM ecosystem towards an open, open systems architecture, Java, Linux, all the open source tools you can imagine, think about it. I'm not saying that you should or shouldn't use IBM MQ. It's a great product, but you might also want to consider Kafka. Kafka has different benefits. And if you want to use Kafka instead of MQ, make that decision at the time of the modernization and let CloudFrame Renovate fully automate the refactoring from MQ to Kafka for you. The other thing that we look at is the legacy languages. They had all sorts of constraints on how many characters, variable names could be, function names could be, just unusual constraints. And it just goes back to this sort of the reality, the scarcity of compute and storage and all the other things that these languages were designed to operate in. Well, you fast forward 60 years later, we have machines, you can have machines with hundreds of gigabytes, terabytes of memory. We're not dealing with these constraints anymore. The most constrained resource we're dealing with is engineering talent and time to solve the problem. So we look at things like being able to apply a dictionary, to rename variables, to bring knowledge of the domain, to just improve the readability of the code, to just do that in a consistent way across the portfolio. That's another big mistake that we're just seeing that companies aren't doing. It's the race to say, hey, it gets the same results. Getting the same results isn't good enough. That's table stakes. I got to be able to maintain this code, because if I'm not getting the benefits of being able to maintain it and move faster, I could have just left it on the mainframe, right? So I always just go back to why. Ask yourself the 5 whys. David, do we have any questions from the audience here?
Not right now, but I do have a question for you, Greg. If you could back up for a second, back to maybe the context question. And I think you mentioned something that I wanted you to maybe clarify for a second. When we're talking about the context that goes into intelligent automation, you've mentioned several times in conversations that I've overheard and eavesdropped into, that if a translation or transformation tool is just moving one line of COBOL code into Java or .NET, it experiences some difficulty. Can you tell me what other mistakes are made there around just assuming that the COBOL code, the COBOL program code itself, is good enough to perform transformation?
Yeah, I mean, I can give you a couple examples. The issue you're describing is, that the industry has settled on the term JOBOL. Java that looks so bad, it literally looks like it's code in another language. There's things you need to do to take some of these legacy concepts and move them to a modern language like Java to achieve the performance that is necessary to match the mainframe speed while still making the code maintainable. And there's a lot of weird anti-patterns in COBOL, and I'll just go back to this very first slide, right? You start thinking about variable length data structures in COBOL versus how you handle that in Java with collections. And it's very elegant in Java, but the code does need special handling. There's a lot of weird behaviors around, people did all sorts of, we're working with some of the biggest, Standard & Poor 500 companies. And we see code 20, 40, 50 years old. And you literally see things like negative, index ranges where you're going outside the range of a table, manipulating memory. And it's actually by intention. I mean, I guess these are like stupid programmer tricks. And you need to maintain the functional behavior of the code without creating something so convoluted in Java that nobody knows what the hell it's doing and you can't maintain it. And there's other just strange beasts in COBOL that just don't have a natural sort of behavior in Java. Like another great example is in byte-oriented languages like COBOL and C and assembly and PL1, they do sort of like, if you say assign variable A the value of variable B, these languages literally do deep copies of the underlying storage. That's how COBOL works. Hell, that's how a lot of languages work. Java is very efficient when it's doing string manipulation. It just assigns a reference, which is like saying it's copying 8 bytes or 4 bytes instead of 10, 20, 50, hundreds, thousands of bytes. So there's all these special considerations that need to go into it. And context definitely matters, because sometimes you can apply optimizations that are natural and intuitive to a Java developer. And sometimes you need to know, I need to do a deep copy because of X, Y, and Z reasons. And you want the code generator to sort of put some hints in the code so that your developers recognize these patterns and they can refactor them away over time. Otherwise, what happens is you end up with a perpetual license lock into a runtime so that you can run code that you wrote and then you paid to convert to another language, and now you're still paying to run it. So that's a hot button issue for me.
Yeah, I hear it in your voice. Speaking of other languages, we did have a question about the ability of CloudFrame's products to work with other than COBOL languages. So we talked about, we're focused on COBOL. That's our tagline. We're very proud of that. The cure for COBOL. Maybe you can address that and talk about what you might see in the future, not near future, but distant future. Does our platform have the ability to consume other languages and generate Java from those?
It does, and I'll give you some examples of how we're already doing that. So we talk a lot about COBOL because it's a problem. It's certainly a problem to solve, but there is a lot of business logic in languages that are surrounding COBOL. So, for example, batch. Batch is orchestrated through job control language, JCL. CloudFrame takes JCL and uses that to effectively build a Spring Batch driver for these COBOL programs that have been converted to Java. Mainframe, the sort utility, df sort, sync sort, they're not just sort. These are super powerful ETL and reporting tools. And I'm guilty of it myself, just because sort was so fast and it was so terse. In 5 to 10 lines of sort control cards, I could do the equivalent processing of thousands of lines of COBOL. So we provide support for df sort statements. So yes, we convert those into something that is usable at runtime, because we provide emulation of mainframe file systems for customers, when they're running in Linux or Windows, so that they can, gradually move their data, incrementally, progressively modernize until they want to move to, say, a cloud NoSQL database, or blob storage, or relational database. There's a need to, for the JCL to have support for utilities like IDCAMs, vSAM operations, IEB gener, IEB copy. So, we've reached into the immediate surrounding COBOL ecosystem, and we've proven we have a tool that can do any-to-any modernization, but our focus is COBOL. We know that we will eventually come to things like PL1, but we want to be comprehensive. We want to be known as the company that provides the cure for COBOL. And then we'll take that cure, and it'll be real easy to drop another language and another language and another language into that robust platform.
Right.
So
okay. Thanks.
Yeah, you're welcome.
One other question before we jump off, and I think you've already answered this with the reference to Spring, but the question was around COBOL, and I assume the Java that it's generated and its relationship to implementation of microservices on the target platform. So I think the Spring framework kind of works to help us do that. Is that the correct answer?
I think that's a fair answer, right? Spring and other frameworks are used for the creation of microservices. I tend to have a definition of microservices that's more consistent with like a Netflix, Spotify, Amazon definition, where a microservice is an operational construct. It's an empowered autonomous team, and they're responsible to create software, deploy it. No offense, David, marketing got a hold of the term microservices and they started using it to describe a collection of technologies and different architecture patterns. Then there's nothing wrong with that, but I don't want to, conflate, hey, I use Spring Boot, therefore it must be a microservice. With a microservice is much more than that, right? It's about these, empowered autonomous teams building 12-factor apps, implementing API lifecycle management, working to delight the peers that depend on their services as well as the customers that they serve, and doing it in a way that is, economically advantageous to the company that they work for. It's a lot of things. It's not, it's not just hey, I used a technology. So let me wrap it up here. I'm just mindful of time. So the cure for COBOL, right? I'll share a story. I ran the '98 New York Marathon, and this was very memorable for me. Nike was giving away runner's gloves. On the left hand, it had a statement: "It's time to stop asking questions." On the right hand, it had a statement: "And start answering them." It's been over 25 years that I've watched tech leaders just ponder mainframe modernization application. And you think about everything that's happened in the last 25 years, right? The internet became powerful, ubiquitous, smartphones, self-driving cars, gig economy, private companies entering the space race, public cloud, cloud economics, the business case for software delivery management, and the science of DevOps, right? I could go on all day. I love this stuff. So my question is, like, you came to the webinar, or maybe you're watching this on YouTube a week from now, like, what's holding you back, right? Reach out to me on LinkedIn if you want to have a private conversation, right? I'll leave the salespeople out of it because I like to geek out on this stuff. But in all sincerity, it's time to stop asking questions and start answering them, right? Keep it simple, right? Deliver incremental benefits quickly, sustainably, and use intelligent automation so that you can manage risk rather than seek it, right? That's the problem that we're here to solve. We want to help people succeed and modernize these systems so that, many of the companies that we're helping, we're customers. And we want to see you get better. Otherwise, we have to go through all the friction of, changing banks or changing brokerage companies. Like, we sincerely want to help you. So thank you. We are the cure for COBOL.